Okay, in this video we're going to look at some additional types of equations, and those are solving equations with separated unknowns. Again, if you got the packet, this is on page 8. So one of the things we need to consider when solving more complicated equations is the idea of combining like terms. In algebra we have this phrase called combine like terms, and like means same. And when we're solving equations, especially the variable we're trying to isolate, we need to get all those variable terms together on one side of the equation before we can begin to solve it or isolate it. And combining like terms have the same variable. For example, 7x and minus 4x, those are like terms, but 3a and 4b are not the same variable, so they are not like terms. It's analogous to thinking of like apples and bananas. 3 apples and 4 bananas are not the same thing. Even though they're both fruit, they're not exactly the same thing. We can't really add them together, unlike the x's here, or if we had all apples or all bananas or something. To combine like terms, we just simply add the coefficients, and the coefficients, remember, are the numbers that are multiplied to the variable. That tells us how many of each we have. So like 5r plus 6r equals 11r, or minus 2d plus 9d equals 7d. Alright, so let's take a look at an equation. This example, 4 is equal to 7x minus 3x. Alright, so again, to begin to solve, separate left and right sides. As they get more complicated, you definitely want to be able to separate your left and right sides. I have messy handwriting, so I definitely need to do that for myself. So notice the variables are all on the same side for this equation. Okay, so we want to combine those like terms. 7 and 3 make 4x. Okay, then we go back through and do our problem solving like we did before. Do those inverse operations. X is being multiplied by 4, so we want to divide by 4. Both sides and simplify, and in this case we'll get x is equal to 1. And we always want to remember to check it. 7 times 1 minus 3 times 1 is indeed equal to 4. 5z plus z is equal to 24. And z should be equal to 4. 5z plus z is equal to 6z, and 6 times 4 would give us 24. Here we have another example. What would be the first step to solve this equation? D over 2 plus d over 2 is equal to 3, or half of d plus half of d is equal to 3, or d halves plus d halves equals to 3, whatever, however you want to read that. What would the first step be to solve that according to these multiple choice answers here? If you answered C, you are correct. In this case, because these are like fractions, we're not actually going to add the 2's together. So we get d over 2 plus d over 2 gives us 2d over 2. What will this one look like after we combine like terms? 3/5 a minus 1/5 a plus 3 is equal to 17. Well, 3/5 minus 1/5 is equal to 2/5, so we should have answer A for this one. Okay. If we have variables on both sides of the equation, we want to get all the variables together on one side of the equation. Combine like terms again. Put those terms together. Doesn't do us any good to have them on either side. We need to get them together. So, how do you do that? Well, it doesn't matter which term you choose, but, and this is through my experience, I'd like to say that try to cancel the one or get rid of the one that will keep your variable term positive. It's not always going to happen, but it sometimes is a good rule of thumb just to say, okay, which one should I deal with? Well, get rid of the one that'll help keep your things positive as much as possible. It's not always going to help, but it's always nice. At least for me it is. So let's take a look at this one. Okay, separating left and right sides. If you need to use a see-do table, go ahead and do that because there's a lot of stuff going on. Nice to organize your steps. I always say subtract the smaller term from both sides. Get rid of that smaller term, whatever that smaller or lesser term might be. In this case, it's the 3x. So because 3x is positive, we want to subtract it. Okay, and when we do that to both sides and then we simplify, we're going to get the x's all on one side, which is what we want. And now we can follow another see-do table or whatever other steps you see if you're comfortable with it. Add 1 to both sides, simplify again, and we get our result of x equals 3. Checking our work. Indeed, we get 11 on both sides. Okay, trying this one. Okay, again, you want to look at what's the smaller term, and in this case, we have minus 3y, which is actually our lesser term. Okay, our smaller term. Remember, negatives are always lesser than positives. They're always worth less than positives are. So even if you had, say, a negative 8y and a positive 3y in this case, then you'd want to deal with a negative 8y. Notice how that keeps things positive, because now we have here 8 plus 3, which will give us a positive 11. If we were to go the other way and cancel the 8y, let me back it up here for just a second. If we were to cancel the 8y, we would end up with minus 8y on a minus 8y on the right side. We'd have negative 3y minus 8y, which will give us a negative 11y. You know, and we can still work with negatives. Maybe you're comfortable with negatives, but for me, I like to keep things as much positive as possible. So I'm going to stick with the 3y. Either way will actually work, but one way I think is preferable to the other. Okay, so we get a positive 11y minus 9 equals 2. And then following our steps, simplifying, bringing down, simplifying, and bringing down, we get y is equal to 1. Check the answer. Both sides do equal the same amount. 8 plus 1 minus 9. Or 8 times 1 minus 9 is negative 1. Negative 3 times 1 plus 2 is also negative 1. Right, another multiple choice. What's the value of x if you have 3 minus 4x plus 18 equals 18 plus x? If you chose negative 3, you are correct. Okay, now we have some fractions involved here. Fractions with variables on both sides. All right, now here's the trick. All right, remember, a fraction is just a form of division. But in this case, we've got parts that are being divided by 2, by 4, by 8. So we want to be able to deal with this as quickly as possible. So we could multiply things by 2. We can multiply things by 4. We could multiply by 8. No, undoing those various divisions that we see in the problem. But the nice thing is, since 8, 4, and 2 all have something in common, if we were to multiply by the least common denominator, the lowest common denominator, which in this case is 8, we can actually take care of all those denominators in one shot. If we multiply everything by 8, all of those fractions will become whole number parts, whole number coefficients, and it doesn't change our equation. The properties of equality say as long as we multiply everything by the same thing, it's not going to change our result. Right? If we simplify, we get this. All whole number terms. No more fractions. We might still get a fraction for an answer, but while we're working on it, fractions are gone. Right? Now we're back to the problems like in the previous slides. Okay, we're going to keep the smaller term. We're going to keep the 4, but get rid of the smaller term 2. 2x. Simplify. Bring down. Add 6 to both sides. Simplify. And bring down. Divide both sides by 6. Simplify. And bring down. And see, we still get a fraction for an answer. That's okay. fractions are going to be there. Fractions are more, they're more common than whole numbers are. But during the process, we kind of avoided the fractions, even though we ended up with a fraction for our final answer. All right, we can check it. If you like decimals, you can do decimals, or you can do fractions, either one. All right, so what would the LCD be of this one if we wanted to cancel all the fractions at once? What number works with the denominators of 7, 2, and 3 all at once? Well, that would be 42. 6 works with 2 and 3, but not 7. 14 works with 7 and 2, but not 3. 21 works with 7 and 3, but not 2. 42 works with all of them. All right, if you want some more practice in that packet, pages 8 and 9. All right, we're going to quickly look at grouping symbol problems too. Okay, what do we do with grouping symbols? Now there's different things we can do with this. Depending on what your skills are and what you know, there's a couple different ways to go about this. I'm going to show the way that I was taught originally, but there certainly is another way that you can do this. So, separating the left and right sides, I use the distributive property. And I want to multiply through and get rid of those parentheses. Now, some people might go, let me step back a second. Some people might want to go, okay, I'm going to divide both sides by -7. You can certainly do that as well. That's another thing that you can do. That will also give you the correct answer. Sometimes that'll work more efficiently than distributing through. I'm going to show distribution in this example, but we can certainly do the other way. Distribute to get rid of the parentheses, follows the same steps. Simplify and bring down, and you get your answer of 4. If you were to go divide by 7 first, you would have a different number than 21 to work with, but you would still get 4. Okay. 3 times the group of x, 3x plus 4 equals 2 times the group of x minus 1. This is where distribution might be a little bit easier to help you solve it, rather than trying to divide by 3 or divide by 2. Okay, should get -14 for that. I'll let you pause and figure that one out. Again, this one, dividing by 8, dividing by 3 may not help you as much as distributing through. Correct answer would be x is equal to -8. And I'll let you figure that one out. Leave some comments below if you have any questions about how to work through these. All right. Again, if you want some practice in the packet there, see exercises page 10 and 11.